This is Mike Møller Nielsen from Java Code Geeks, and I'm going to teach you how to write clean, efficient Java code using the Git source control management system. If you've always wanted to place your code under source control management, then this video is something for you. Now, we have related articles and links in the description below. Also feel free to like, subscribe and hit that notification bell so you know when we have more stuff coming up. Now, without any further ado, let's get started. So which problems is it that Git solves for us? Let us look at how versioning was actually done if we would not have an SCM system at all, a source control management system. The short for that is the abbreviation is SCM, source control management system. Then let us say that I have my file.txt on my own machine. Then I am editing this machine, and I still want to have the old version, so I can always go back to that version. What would I do? I might be tempted to create a new file where I then rename the original to something like underscore this year, and then the date, and then maybe also the day right here, and then _1, because this was the first edit that I did today. So then I have this file right here, which has this new name in it, and then I have the original name for the changes that I do make. Then I open my txt file, then I do some work. Then I want to save this state for later use. Maybe I'm not sure if this would be approved by my colleagues. So then I take a copy of my file. Again, I take a copy of my file right here. And again, I have to give it another name, like 2022. And then 07 for July, and 17 because it's 17th. And this is the second change I've done today. So I'll name this _2. And then again, I'll do my changes in the file, and then so forth. Of course, as you can see right here, sometimes I would actually also add my name to this file right here, because my colleagues could actually edit the same file at the same time. Maybe they have that file on their own machine, or maybe on a common shared drive, and that is actually what happened in the old days. Then you would have files placed on a shared drive, and then you would work in different versions like this, and then you would try to have to put them together afterwards, and then merge them so they actually made sense to some result that could be used for the company. So this is without source control management system, and this is exactly what it solves. It solves the collaboration between colleagues. It resolves the traceability, the audit, so we can see what actually happened by who and when. And that is why Git is so strong, and it is a de facto standard today. At some point in time, there was actually something called Mercurial, which was also kind of user-friendly and good. But Git has more and more popularity, and then Git is kind of the de facto standard that is being used. So what happens in this normal Git flow right here? You can see I have something called a local Git repository. This Git local repository is actually just a history of what actually happened at any given time, moment in time, and by who. So that means that if I create some change in my file.txt, then my history inside my local Git repository will then get an addition like this, git id 2. And right now I'm just naming them git id 1 and 2. They actually have the long hash, so they have this long ID. And which we will see very soon. And in here, they will actually say that my file.txt was changed, and they will also mention the changes on inside the file, which lines were changed. And then I can it is of course only if I commit this my file.txt. And what I did when I actually pulled it into to the Git repository it's called staging. So first we have to stage or file. We have to say that I want this file to be monitored by the Git repository. That's called staging. So staging is like adding it to the Git repository, and now we want to have an audit trail for this file. That's called staging. A commit is something where we commit a change. It could be multiple files that have been changed at the same time. Then we can commit with a message where we say that why we have done this change here. I have made this change in my file.txt. And this could be a description of installation of the software that we're creating, or something like that. This is called the commit message, what I added right here. It will also, my history will also store that it was Mike who did it, and it will also have a timestamp. So it will also say that this is today, now, and the exact nanosecond. So this is how the local repository then works. Then at some point, I want this to be shared to the remote repository, because then everybody else can then download this change with something called a Git pull. But before we could do that, then we actually have to push this change. Before we push any change, then we would also always make a pull, because my colleagues could actually have made some changes in the meantime. They could actually have created their own myfile.txt. Then we would end up with something called a merge conflict, which is a bit of a more complex concept, but it just means that there's no easy way to merge those two changes together. You have to look at it and then decide which one is the real version. That is a merge. So whenever you hear a code merge or a Git merge, then you should just, it's just that we have to have some kind of developer, some kind of user actually look into the problem and the changes that have been made, and choose which is the right version, which one is the one that we should actually store, and which one should maybe be renamed to something else, or changed, or moved to another file. First, I make my pull in this situation right here. The history only has ID 1, and I have created ID 2, and I also have I have ID 2, so mine is actually newer. There's no new there are no changes that I need to pull. This means that I will actually I'll get no changes down when I pull this code right here. Then I write git push. This means that I will actually push my own local repository's history up to the remote repository, and the remote repository says, I don't have Git ID 2, and we can just go ahead. There's no one else that has pushed any code in the meantime, so there are no code conflicts, and we do not need to merge. So I'll just add this to my remote Git repository, and this happens in most of the situations. In most situations, there would be no merge conflicts at all. It's very rare that there will be merge conflicts. However, they can be quite difficult to solve sometimes if it's a lot of files that has been committed and pushed, and that is why it is recommended that you will make small commits, and that you will push and pull code very often. Then you will get the least work with the code merges whenever you end up in with a conflict. So this means that my colleague can then also take this code down right here by making a pull, and then my colleague can then change my file. Maybe my colleague will actually rename my file to something else. Maybe it should be readme.markdown instead. That was the right name that we agreed on. So then my colleague will then rename this file right here. My colleague will then commit the change. So we get a new Git ID 3 right here, and then it will say that rename to readme.markdown, and it will also have a message which could be I renamed it due to the meeting we had earlier on. And then again, there will be a date right here, a timestamp. There will be a timestamp right here with the time and dates of when this change actually happened. And again, then my colleague will then, after committing this, then when my colleague will push this code right here, and this will then be the new source of truth right here. And then whenever I try to make a new change, then I have to I cannot push my code because there was this Git ID 3 right here. So I have to pull my code. I have to pull this change before I can actually push some new code. So this means collaboration. So this means that we have everybody actually has a version of the truth on their own machines, and then we add to that truth of reality, all of us, and then sometimes our version of reality actually conflicts a bit because we have been changing the same files, the same lines maybe, and then of course we have to solve that with Git merge. So that is the idea behind Git. Of course, this looks very, very simple, but it is actually quite advanced, and it is actually quite difficult to be good at Git. It is easy to obtain the basic skills, but the advanced skills can be a little bit difficult, especially regarding conflicts and merge. First of all, let us see how do we actually install, how do we get Git on our machine, and it's quite easy. If you go to git-scn.com and then /downloads, then you can get the version just by choosing whatever version that you have. I'm running Windows right now. If you're running WSL or if you're running Mac, then you would choose the Linux or the Mac version right here. I've already installed it, so I have pressed this Windows button right here. Then I installed it. I got several pieces of program with that. I got Git by itself. I also got something called Git Bash. I would definitely recommend you to use Git Bash whenever you run your Git commands in a terminal. Just start up with Git Bash. It is just like your command line, but it's just a Linux-based one. So if you're familiar to Bash, then of course you will also feel very familiar to Git Bash. And the current version right now is 2.37.1. And that is also one thing to be aware of. That is that all of you should actually have the same version of Git in your team, I would say, because when you are trying to help each other, Git actually acts differently depending on the version that it has. Another thing I just want to mention before I show you some cool code and some cool Git commands is that there's actually something called cheat sheets. And if you search maybe through Google on cheat sheets, then you will get a lot of results. And I'll show you some of the results right here because they are very good to have in the beginning. Atlassian has a cheat sheet, and actually most of these vendors for the repository, you can see right here we have a remote Git repository right here. There is a lot of money in actually creating these remote repository systems and being a vendor for the Git code right here. So there's a lot of competition, and usually it's free to use if it's open source, and we also have a number of Git repositories that you can actually create for free and start up by free. And then when you want to collaborate with your colleagues, and if you want to have any repositories, then usually there's a paid price plan that you have to follow. But since there's a lot of competition, then most of these vendors, they have also launched their own Git cheat sheet because of course they would like to help their customers as much as possible. Atlassian is one of them. They have released this one right here. Git. Here we can see the cheat sheet right here. We will go into to the meaning of these in just a couple of minutes right here. But I just want to show that they are here. We also have GitLab, which is another product. And here again we have the cheat sheet, and they are almost showing the same commands. And of course it is the same underlying product, Git, which is also of course free to use Git. So of course it is the same. It's also almost the same cheat sheet they have made. Then we have GitHub.com, and the GitHub.com, that is the vendor that we are going to use for this demonstration right here. And again, here we get a lot of help. So we will use this GitHub cheat sheet for further on here now. So one thing that I didn't tell you regarding this Git repository right here and your local Git repository, you actually need there needs to be some security. There's some security involved because anyone can not just commit code to your repository. There needs to be some security behind that, and that the security that is used is SSH, which is a secure socket shell. That means that you need a public and a private key. Remember that the private key is the one that can decrypt communication. You should never show your private key to anyone. The public key is the one that encrypts communication. So you can give your public key to anyone, then they can encrypt communication for you. And that's also what we're going to do. We are going to create an SSH private and public key pair. And then we are giving the public key to the GitHub. To the GitHub system, so it actually knows that this is me that now wants to check out some code. Let us try to do that right away. I have Git Bash right here. That is the Git Bash that we talked about, and you just write SSH keygen like this, and then you will get some questions right here, like which file which file name should be used. If you haven't a private key, public key set already, then you can just press enter. I already have one, so I'm going to create a new one, which is named Mike demo like this. And then I press enter, and then it asks if you want a passphrase. This passphrase is if we want to use the private key, then we need to apply this passphrase. I'm going to keep it simple, so I'm not adding a passphrase in this situation right here. And let us just let us just check right here. We got an error. Let us just try again right here. So let us just try. Yeah, I'll just copy this part right here. I had the first forward slash should not have been there. I'll paste this one again. Users mic m and then .ssh. With Linux, you always have a dot in front if it's a hidden folder. I'll try again. And this should actually be okay. Okay, let us just try with mic right here. Copy. Paste. Okay, that was. So now maybe the file name was too long or something. I don't know. But with mic it was okay, and I had a forward slash in the beginning right there. Per default, we use the encryption standard named RSA 3072, but you can choose your own encryption standards. You can see on GitHub which ones are supported, but if you don't know which one you want, if you don't know, then just use the default. That's okay to get started. And let us look in this SSH folder right here. Now I have a mic file right here, and I have a mic.poop file right here. The .poop, that is the public key, and that is the one that we can give to. We can give this to anyone because the purpose of this key is to encrypt data. So that means that it's okay. Everybody can encrypt data, but they should not be able to decrypt the data. That is the whole purpose of having this right here. So in this situation, I'll delete this key in just a minute. So when we are done with the demo, then I'll delete this key. So I will also show you how the private key actually can look like. It looks like this. So the private key, there's a bit more in it. We have a beginning right here, with some dashes right here, and then we have the key here, and then we have an end part right here. That's just how they look. Let us add the public key to GitHub. I'll just show you how to do that. So again, we will pub cat, that just means show the content of the file. Then I'll copy this part right here. Copy. Then I'll go to GitHub. I've already created an account. If you did not create an account already, just go and create one. It's free to create an account right here. Then I'll go and look at my profile right here. And then I will say, I'll find settings right here. And here there's a menu point right here. I've chosen the dark theme. That's why everything is black right here. If you have chosen the default theme, or not, if you haven't chosen any default, any theme at all, then it would be like white right here. I'll say SSH and GPG keys. And here I have all of my keys. And then I can add a new key right here. Of course, you can have multiple keys because you could have multiple devices that need to have access to demo, delete afterwards, like this. And then I'll paste my public key like this, and then I'll say add. And then I need to type in my password, which I'll do here. And it is okay because I already have some other SSH keys which have been accepted, so I will actually I'll not add any more SSH keys than I already have right here. Actually, I'll go right away, and then I will delete the other files that we have right here. So I'll say I'm mic.pub because I've already added some of the other keys that are right here. So now let us create a repository. Let us create a project here. You would actually just say new. And then it asks you, should it be public or private? That is actually the important part. Should it be a private one or should it be a public one? I'm just going to choose a public one right now. This means that you actually don't need to have the security enabled. If the security is teasing you a bit, then just choose public because then you don't need any security at all. I'll say git demo 1 like this. And then I'll say this is a demo for Git like this, and then it's public. Yes, I can now add a readme.markdown file. I think this is a really good idea because then you have one file that actually describes your project and what you're going to do, and then you can start by actually editing this readme.markdown file to actually get a hang of what you're doing. Then there's a git ignore file. If you want some files that should not be a part, that should not be staged, that should not be other source control management, like all of your binary files, then you need to add those to a .gitignore file. Let us just create one right here. I'll say that this could be some React, or it could be JavaScript maybe, just Java. So I'll take a Java ignore template right here. There are actually some sites out there that are quite good, where you can choose exactly what kind of code you have, and I can also choose a license right here. I'll just choose the Apache license just for fun. Actually, I'll say none right here. Let us just keep it simple right here. And now it says that this will be the main branch. This is because Git actually supports something that we have not been talking about yet, and that is branches. We can have multiple branches, so we can have someone coding on a new feature, and then they will not step on the toes of the rest of the team if this feature, if this feature maybe might refactor a lot of files. Then they can work on it on their own branch and see that it works before they have to commit and push the code. This is called branches, and there's actually something called Git flow, which is a quite complex work setup where you have multiple branches, like you have main, you have a test, and you have a development branch, and then the code then moves from one branch to another at some given point. We will not go into that right here. This is a tutorial of Git, and this is just the basic stuff that I'm going to just to explain to you right here. So now I've actually created my repository, and now I would actually like to clone this repository right here. I would like to get it out, and how do we do that? There's a green code button right here. Here I can say that I would like to use SSH. If you don't want the security part, then you just take HTTPS right here. But we want to also the security part to be included. Then we say SSH. Then I will copy this one right here. And then I will go to my bash console right here. Then I'll make some kind of folder. Demo. Then I'll go to my demo folder right here. And then I will say git clone. So that is the first thing that we need to know. We can git clone, and then we need to add that. Let me just paste. We'll just copy once again right here. Copy and paste. Say git clone right here, like this. So now I'm cloning this project right here, and because I have the SSH key. The public key is actually added to GitHub, then it will actually accept me as who I am, and it's also a public project, so it would actually have accepted me anyway, even if I did not add this SSH key right here. Okay, so let us see what we got. We got a folder named Git Demo 1, so let us go to that folder, the Git Demo 1 right here, and then I got one file. So that is pretty good. That is pretty good. In the beginning, it can be quite difficult to handle all of these Git commands. So of course, you need to know about git clone to get the code out like this. But I would definitely also recommend that you use VS Code or another system where you can actually find your all of your stuff right there. And let us just see where we are right here. Say pwd like this, and let us see. This code can find that location right there. We go to C users, mic demo right there, and git demo right there. And then I say select folder. And yes, we trust this folder right here. So here I have my readme.markdown file, and then I have my git ignore file right here. And as you can see, these are all the binary files. These are jar files and wrap files with zip and tar. And they're also compile file like class file, because I said that this should be made for Java. And then I have my readme.markdown file right here. Let me just make a first change. So we'll say this is a demo, first commit like this. And then let us see what actually happens inside. This code. We can see that now we have a blue mark in the left side right here. So we actually have source control management included into our IDE, and that is very normal. And it doesn't matter whether you're using IntelliJ, or if you're using VS Code, or if you're using WebStorm. Most of them have some kind of source control management system integration that makes it easy, especially in the beginning. In this situation right here, I can stage the file by pressing a plus, but I don't want to use VS Code yet. I want to use the cheat sheet so we can actually get started with the commands to begin with, and then we will move over and use Git, use VS Code in the end when we know what we're actually doing. So here we have the GitHub. So the first thing it actually says, it says you need to configure Git and say which name you have, and this is a very good thing. You should always start with that actually. And this is so other people can, so the Git system actually knows who you are, and it can actually give, it can show, I can give a good list of who did what. So let's go to Git bash, which here. Let's clear this one right here. Then I'll paste what I got from this cheat sheet right here, username. Then I'll say Mike Nielsen like this. So now I've configured that. Let us go back to the email right here. So this is the email. And again, I'll paste this in right here, and I'll say my email, and then I'll press enter. I've already done this, so I'll not do this once again. And then there's also something with the coloring. So if you want to change the color UI, then we can also do that. Then we have something with a setup and init. This is if we want to create a new repository locally instead of using GitHub. We use GitHub to create this repository right here. Then you can just write git init, and then you can then push this. It's a bit more difficult to afterwards to push that, but there's a good guide on GitHub on how to actually do that if it's a repository that you already have right here. Git clone, that is what we did. We created a repository on GitHub, and then we then cloned it out. When cloned is just getting an exact copy. So we got a folder with the files and also with the Git history. Then there's something else right here, which is very important. Git status, that is a very good command. Let us just run that and see what actually happens. Git status like this. And here I can see that your branch is up to date with region main. That means that I have what I should have from the remote server, but it also shows me right here that I have a modified file right here. There's something right here that is not staged for commit. This means this file is not being, even though if I made a commit right now, this readme.markdown file would not be included and would not be staged. So what we need to do is we actually need to write git add, and Git actually helps us right here. It says git add. We can also say git restore. What that will tell Git is that we do not want Git to control this file. We still want the file to be placed on a file system, but we just don't want Git to handle the source control management part of for this file right here. If we say git delete or git remove or git delete, then it will actually also remove it from the Git system also right here. So we have two options right here. We have git add and git restore right now, and I will say git add. It'll say readme.markdown like this. Then I can write git status once again. Now it's green because now it has actually been staged. So your branch is up to date, and there are some changes right here that they are not committed, but they are changed. Let us just jump back to VS Code just to see how it actually looks right there. Look, now it actually went from changes to staged changes. This means that we have staged our first change actually. So let us go back to our cheat sheet because now we have staged it. So what should we do with it? We used the git add right here. We did not use git reset because we wanted to handle this file to be handled by Git. And then we have git diff that shows what is the difference, but not staged. Okay, we can also try that one, and we can also try to make a commit. And this is actually what we want to do. We want to make a commit, git commit -m, and then some kind of message right here. But let us run git diff just for fun to begin with. So we will run git diff, and right now there's no changes because we can also try with the stage -1 stage right here. And when we add the stage, then we can actually see that we have that we have added some lines, and we have also there's some lines in the first version that are not there. And then we have added some versions right here. There's some part right here, and these are the lines that have been added right here. We have added these two hashtags right here, and then we have added this is a demo, first commit, and then we have added one line here and one here. So now let us try to commit this part right here. So we write git commit -m for message, and then we say this is my first commit. And then we write nothing more. Then we just say enter. Okay, now it says this is my first commit, 1 file changed, 5 insertions. Again, let us go to VS Code to see how it looks now. Now VS Code is actually done because we have actually committed all of the files that are right there. We can synchronize changes. What this will do is a git push, but it will actually first create a git pull, then it will actually do a git push. But we want to do this manually right now because we want to learn about what's going on. So we write git status once again. As soon as we don't know what the status is, then we write git status. And here we can see that right now there's no files because we have committed and your branch is ahead of origin main by 1 commit. Use git push to publish your local commits. That's what it is. Use git push. So let us try to do what it actually recommends us to do. Git push like this. And it looks like it went okay. It said it moves some data. It moves some data up to the remote repository, to the main branch. This is because we're only using one branch right now, that is main branch. It's also the most efficient way to work is actually if you can minimize the number of branches that you have. The more branches you have, the more overhead you will have of moving code between these branches, and the higher a risk there will be to suddenly have some huge merge conflicts and some huge some huge code conflicts that will actually take a long time to fix. So try to work together, try to work on the same branch and commit and push and pull very often, as often as possible. But now we have pushed this. Can we now see this on GitHub? Yes, exactly. Let us just check if we can. I'll just go refresh this page right here. So this is my repository right here. And now I can see this is a demo first commit. Wow. So we've already created this. That's quite good. Can we also view the other files? Yes, we can actually with GitHub. You can actually go and you can also look in these files. You can actually also create an edit. You can also edit the file and then you can create the commit on GitHub itself. I would not recommend this because, especially if you're dealing with a Java project, then you cannot see the consequences of what you're doing. Yeah, you should do your changes in your IDE because your IDE actually knows the dependencies and knows how your modules work together. And maybe you change something where another submodule actually broke because of the change that you made. And we should also have some good unit tests always that should be run before you do your commit and also before you do your push. You can actually automatically have your test run by adding something called a Git hook. I'll not go into that in this video right here. It's a little bit complex, but you can just add Git hooks. This is just the things that will happen automatically every time you do something with Git. Then you can have your tests run automatically. And if some of your test fails, then your action could then also fail. Then maybe your commit will also fail. So maybe you cannot commit files if your tests don't run. That is one option. Now let us try to add a new file just for fun. So this time we will use VS Code. So I'll say give me a new file, my new file.txt, and here we could have like a recipe, recipe for bread or something like that, and then we have a lot of cool stuff right here. And then I'll save the file. This time I will use VS Code. Then you can see the change. Then I have to press plus to stage it. Remember that we have to stage the file. So first we have the file right here. We have to stage it so the local Git repository actually knows about it. That is what we do by pressing plus right here. Stage changes. Yes, thank you very much. Now and then I have to give a good commit message. That's what I do right here. My recipe for bread. Then I can press Control Enter, or I can press this V right here for commit. I'll just press the button right there. Then I can press synchronize changes. What will happen right here is a pull will happen, and also a push will actually happen. So we will go back and look at the status. I'll just clear the screen right here. Git status. Let us just see what happened. Everything is okay. I can write git push. Everything is up to date. Git pull. Everything is still up to date. Yes, and let us try to go to GitHub, which is right here. So just for fun, I'm going to refresh this page right here. Now I can see my new file.txt, and I can see my recipe for bread. It's right there. Now I'm going to make a change that will actually create a conflict. I will do this on purpose. So I will say this is not a recipe for bread. This is all wrong. This is recipe for buns maybe instead. And we need to add sugar, and we also need some milk or something like that. So this is what I do right here. So that means I'm actually creating a change directly, and this is my commit change right here. Buns, not bread. That is the description, and then I say commit directly to the main branch. Yes, do that. So now I've actually committed something which is not, which I don't have on my local machine. This is only on the remote repository. So that means that I have committed some code, a version of my file on a remote Git repository right here, and I have another version locally right now. This is very normal that your colleagues can actually create some changes in your code that you don't know about because you're coding right here. You have this recipe for bread right here. And we are adding something right here. We need some flour. We need some yeast right here. We need a bowl. Maybe we need some oranges. I don't know what we put in this in this recipe right here, but we want to add some more stuff, and we still think this is a recipe for bread. So we are going to save this. We are going to use VS Code as usual, and we are going to state this change. And we're going to put a git my recipe for bread now with oranges. Now we have added oranges into the recipe. And now I want to synchronize the change. First of all, we're going to do this with commands. So what I usually would do is I'll write git push, or first git status just to see what's going on. Then we can see, okay, we are actually ahead of the origin, which is origin that is on the server, the remote one. Then we say git push like this, and let us see what happens. Oh, we got rejected. We got rejected, and how come? That is because someone has updated the remote repository, and we need to make a pull first. Okay, let me write git pull. Usually there will be no conflicts and there will be no problems. We would just get the new files that has been changed down, and we would just get those into onto our local machine. But there's no fun about that, and that is just that will not give you any problems at all. So now we make a git pull, and then we say, oh, now there's a merge conflict. It actually tried to auto merge my new file.txt, but then I found out that there was a conflict. This means that the same lines has actually been changed, and we now need to think about what is the right version, by which lines should actually be the right lines in our file. We can, if we write git status, then we can actually see that both files right here has been changed, and we can actually write. We can use some commands like git merge and all that, and we can also abort if you want to abort the merge. We can also fix them manually and then write git commit afterwards. There are many ways to actually handle it. But let us try to look at the file first. So how does the file actually look like now? So if I go and open my file, then we can see that it looks very, very weird. It's like someone broke this file right here. Someone added this right here head. Then they added all these equal signs right here, and then they had this this weird. It is a git commit hash ID. Let me just tell you that. So then it has this weird one right here. So these are the two versions that we actually have. We have one version which is the head right here, and you can see that is actually from my that is from my perspective. That's my head. This means that is from my machine. And then we have this version that comes from the server right here, and that is from this git commit right here. So head is your local changes, and this is from the server right here. And this is just to say that now here comes the server version. So now we need to choose which version should actually be the right one. We need to solve this by solving this, and the way we solve it is by removing those special all of those characters right there, and then we need to then think about what should actually be the truth. Then we see, it is actually a recipe for buns. It's not for bread. The remote host was actually right about that. And yes, we also need to add sugar, but milk we do not need to. We not need to add that. And maybe sugar needed to be on the first line like this. So, and then we delete all of the empty lines like this. So now we have actually solved the merge. We have merged our file. We have solved the conflict. We've done that by manually looking at each line and actually thinking about what should be the real truth. And now that we know that, then now we can actually do multiple things. We can use VS Code. Of course, that is the easiest part. Here we can, if we just press plus to stage it, and then we can do a commit afterwards, and then everything will be fine. But I want to use the terminal just to show that we know what's actually happening. So what do? We actually say add again. We say add, then this file right here. If we have a lot of files and we don't want to mention all of the files, we just want to add. We just want to stage all of the files that we have changed. Maybe we have changed 10 files. Then you can actually write add and then a dot like this, and you can actually add a whole directory. So this means if you add a whole directory like this, then you would add, and you'll also add your file, the txt and the merge that we did. I will actually do that this time. So I'll just write git add dot, and then we will say git status. Now it's green because the change has been staged, and then we can write git commit and -m, and then solved conflicts. Solve the code conflict, merge conflict, and then by merge like this, and enter. And then we can write git push again, git push. Then of course, what could actually have happened in this situation? Now everything went fine, but maybe another colleague in the meantime would actually have changed the same file once again, and then again you had to pull, and then again you had to solve your merge conflict. That is why it's very good to pull very often, to commit very often, and to push very often. So you're always so you're always synchronized with the main branch or whatever branch that you have chosen to develop on. Also, there are different strategies. One strategy is also trunk-based, and trunk-based is the most efficient one. That is where everybody codes in the same branch, maybe development branch, and then at some point we want to release some code. Then we will then create a new release branch from the development branch, and then everybody will just continue coding on the development branch, and that means that we are collaborating all the time. And then the code from the release branch will then go into production and be deployed at some point in time. That is a whole other story that I will not come into in this video right here. But I think this was. Let us just look at the cheat sheet and see if there was anything that would be interesting. Yeah, if you want to create a branch, how do we create a branch? We will do that. We will also create a branch, and it's actually quite easy. We will write git branch and then branch name, and then we'll actually create a new branch for us that we can code on. Then we'll have git log. Yeah, we also have to see git log. Git log that gives us the history, so that will give us all the changes that actually happened. So we will also run that. Let me just check right here. Git remote. This is if you want to add the remote locally. This is what if you want to add the location of the repository. Right now, it automatically became GitHub because we started by creating the repository on GitHub, and then we cloned it out there. Then the remote will actually be set correctly. Let's say that you start by creating your own repository locally by running git init that we had right here. Then you would have to say. Then you would also have to run git remote afterwards if you want it to be added to GitHub or one of the other repository vendors out there. So let us write git log. Let us just see what happens. So git log right here. This says that this is the main branch that we're on right now. So this is the main branch, and here we get all of these weird IDs right here. This is the IDs. This means that we can also get the code. We can actually check out the code from an earlier commit. So let us say if I get this commit right here, copy, then I can write git checkout, and then I can mention that ID right there. So now I should be back to my recipe for bread. Let us look at the code, and we can see that my new file actually changed, so it looked like it actually did. So it actually looked like it did before we merged the code and fixed everything right there. Then there's a new trick that is git reset head hard. You should only do this if you don't care about your local changes. What this will actually do is it will actually bring you back to. It will actually remove the changes that you've made locally. We do not have made any changes, but let us say I've written a lot of stuff that I wanted to undo. Then I could write git reset head hard like this, and then those lines that I just added, those will then disappear. Again, let us write git log, and then we can say, we can use the name head, git checkout head, like this, or we can use the, see how the git checkout, let us just, okay, that's because we need the original ID, which is right here. Okay, let's copy that again here. Git checkout, and then I'll check out the original, and then we'll say, yeah, now it's oranges, etc., etc., etc. once again. So that is good. So now we're back where we actually were. So that is the git log. The git log can be used to see the all the changes that has been made, and we can also go back in time if we want to see some state. We can also see who actually did this commit, and we can also yeah, we can see the timestamp, and if so it's quite good. This is the audit trail, so we can always see what went on at a given point in time. Let us just write the git branch. So git branch right now, I only have a main branch right there. It actually changed to head right here, and that is because I did that with the checkout. So I need to say git checkout main. So now I'm back at main, I guess. Git branch, let me just check. Yes. Now I'm back at the main branch. Let us also say that we want to create a new branch. Git checkout -b for branch. Then it will create the branch for me. Then I'll create a new branch. Development. It's very normal to have a development branch. So now we have branch right here. So that means that if I make any changes on the development branch and my colleagues they are active on the main branch, then we will not see each other's code changes. So of course we need to agree on how we should develop, on which branches we need to develop, and which strategy that we use in our team. So yes. I hope you liked this video. If you did, then please like, subscribe, and hit that notification bell, because we have a lot of cool stuff coming up. Bye.